Right, on to section 9.2, analyzing rational functions. This is where we have some a little bit of weird stuff that you haven't seen before, that we might challenge already what you think. As soon as you see an equation, some of you are like, oh, that's quadratic. Well, is it? Are you sure? So let's check that out right now. Something weird is happening. So I've got some graphs with their equations. Well, what is weird on the following graphs? What do you think causes this? And what's weird is if I look at the reciprocal function of this, I've got this little dot here, open hole. Well, why is that there? And it seems like it's at a weird point. Like if I look at the MPVs of this, it's x equals 3 and 1. So x can't be those. Well, yeah, at x equals 1, there's an asymptote. So why wouldn't there be an asymptote here? Why is there just this like little open point, open hole thing looking there? Well, the reason is I can cancel out x minus 3 on this. So this graph that you see is actually just 1 over x minus 1. Now we still have to acknowledge that our original didn't have this point, and that's what this open dot is telling us. Now our second one, it looks like it should be a quadratic. It's x squared minus x minus 2. How is that not a quadratic? We have a linear graph here. Well, one hint should be we have a point of discontinuity, and that's this open dot. And how do we see where that occurs? Well, we need to factor this. This becomes x minus 2 and x plus 1 all over x minus 2. Oh, well, if we cancel these out, all you're left with is x plus 1. And yeah, that makes total sense then. And this really is just showing our MPV. And we call that a point of discontinuity. And it's described by an order pair at which the graph of a function is not continuous. It occurs when both the numerator and denominator have a factor that will cancel each other out. Well, we saw that. Now, this single point missing form the graph, which is represented using an open circle. Sometimes this point is referred to as a hole in the graph. So we're going to look at things like that and our canceling with our denominator and numerator and looking at our degrees to see, well, what would these graphs actually look like?